In this lecture, we will discuss about the microtomy. This is next to the embedding. So micro means small and tomy means cutting. In microtomy, we cut the tissue in thin slices so that it can easily be observable in microscope. Now, the instrument which is used for this purpose of microtomy is known as microtome. To master the sectioning method, we have to have a thorough knowledge of the equipment, that is a microtome, quality of the equipment, quality of processing the tissue. So the most important part of the microtome is a microtome knife. There are many types of the microtome knives used before, but nowadays we have a disposable blade for the microtome. So microtome knives is probably the greatest single factor in producing good sections. Previously used microtome knives are of multiple types that were plain wedge, plano, concave, biconcave, and tool edge or chisel shape. So in the figure, it depicts various types of the microtome knives which were used previously for microtomy. The first one is a profile A or plano concave microtome knife. The second is profile B or biconcave knife, and profile C is wedge shape, and profile D is chisel shape microtome knives. So these are various microtome knives which were previously used for sectioning. As we discussed earlier, that microtomes are a device which cut the tissue in uniform thin slices. All microtomes, other than those used for producing ultra thin section for electron microscopy, depend upon the motion of screw thread in order to advance the tissue block and knife at a regular number of microns. So a motion of screw can be direct or through system of gears or lever to magnify the movement. There are different designs of the microtome, but all possesses same basic requirements called a microtome prerequisite. So following are the prerequisites for the common microtome. The first one, it must have a rigid support for tissue block, that is known as the tissue holder, a rigid support for knife, that is known as the knife holder. There must be a mean of movement of either tissue block or microtome knife, and there must be a mean of advancement movement of tissue block toward the knife for pre-selected micron after cutting stroke. So there are various types of the microtomes like Sledge microtome, rocking microtome, and there are some other types as well, but the most common microtome that is used widely in the histopathological laboratory is rotary microtome, which was developed by Charles Sledge in 1986. This is a very simple principle in which the tissue block move across a fixed knife edge in vertical plane by vertical rise and fall moment perpendicular to knife edge. The vertical and advancement moment are controlled by an operating handle, which is in the form of a rotor or wheel on one side of the machine. Due to this shape of the operating handle, the rotary microtome is given the name rotary microtome. So the block holder of the rotary microtome is equipped with adjusting screws to ensure that the block is parallel to the microtome knife in all planes. So there are some advantages and disadvantages of the rotary microtome. First we will discuss the advantages. The rotary microtome is very useful for serial sectioning. This microtome is more rigid than Cambridge rocking microtome. Section of somewhat tough material is also possible. Tissue block of size 3 to 4 centimeter can also be sectioned easily. This microtome is used in Cryostat, which is also known as the freezing microtome. All the other types were initially used. It is recommended for research lab because it gives section of superior quality. It is also recommended for laboratories with high workload because it is easy to operate and tissue of uniform thickness can be obtained with speed for large number of blocks. So there are some disadvantages as well. The first one is this microtome is complex in design and construction, and this complexity lead to its high cost. It is not suitable for large size blocks or very tough material embedded in sliding or low viscosity nitrocellulose, that is also known as LVN. The knife is also dangerously placed. The blade is up. So this image depicts the rotary microtome and its various components, universal cassette clamp. You can see the knife holder, removable section waste tray. You have the handle, you have the locks on the handle. So all of these are various parts of the rotary. Now we will discuss the procedure of sectioning. So first of all, we will fix the tissue block in the block holder of the microtome and then the knife in such a position that it will be clear of the knife when it is in position. A block may be fixed directly or it may be fixed to a metal carrier which is in turn fixed to the microtome. Then we will insert the microtome knife and adjust it if required. The clearance angle should be set at 3 degree and angle of slope should be set permanently at 90 degree. So after fixing the block and knife, we will start trimming of the tissue. Trimming means to remove the extra part or wax from the tissue. So we will keep the block moving toward the knife at 15 micron. That will remove any wax, surplus wax, and expose the suitable area of tissue for sectioning. After trimming, we will start the fine sectioning. So the thickness of the section is set between 4 to 6 micron depending upon the nature of the tissue. Then we apply ice to the surface of the block for a few seconds and wipe the surface block free of water. This step is optional but makes section cut easily. Note that the whole surface of the block will move parallel to the edge of the knife in order to ensure a straight ribbon of sections. The microtome is now moved in easy rhythm with right hand operating the microtome and left hand holding the section away from the knife. The ribbon is formed due to the slight heat generated during the cutting, which causes the edges of the section to adhere. If difficulty is experienced in forming a ribbon, it is sometimes overcome by rubbing one of the edge of the block with finger. During cutting the paraffin wax, embedded section become slightly compressed and creased. Before being attached to the slide, the creases must be removed and the section flattened. This is achieved by floating them on warm water. Thermostatically controlled water baths are now available with the inside coated black. So these water baths are controlled at temperature of 4 to 6 degrees centigrade below the melting point of paraffin wax. It is easy to see crease if the inside of water bath is black. The action in floating out must be smooth, with the trailing end of ribbon making contact with water first to obtain flat sections with correct orientation. Floating out with the shiny surface toward the water is essential. When the ribbon has come to rest on water, the remaining wrinkles and folds are removed by teasing apart or by using forceps or seekers. So this is all about the rotary microtome and the procedure of sectioning.